Take a look at building logic gates from MOSFET. When we are considering MOSFET, there are two types of MOSFETs. One is NMOS and PMOS. And if you look at the symbol of those, it's going to look like this. For the NMOS, it is just the MOSFET symbol right there. And for the PMOS, you will see a symbol exactly like this, but not attached at the end. Okay, this is equivalent to NOT gate. So how does this behave for this is NMOS? Let's define it first. NMOS, PMOS. Okay, 1 second. So this let's say the input is 0, NMOS will be off. If the input is 0, NMOS is off, and if the input is 1, the NMOS is on. But for the PMOS, it exactly opposite. If it's 0, it's on, and if it's 1, it's off. Okay, and if you look at the diagram, the combination of these two, this NMOS and PMOS, make it to CMOS. So for example, we can look at a CMOS that look like this. We can attach NMOS like this and PMOS, and we can see the behaviors. So let's say this is the VDD and this is connected to the ground, and I attach an input at the gate. Okay, let's say this is the PMOS and this one is NMOS, and here I put the input. Okay, here this is, as you can see, this one is N-type MOSFET and this one is a P-type. You can verify by looking at the node at the end. If you don't have a node at the gate, that's NMOS. If you have a node at the gate, that's a PMOS. So if you put input 0, then what will happen? This N-type NMOS is going to be off. Okay, let's say this is the output here. We can analyze what will be the output. So if I put output here, what will be the output? Or you can call it V0 as well, like a voltage output. Okay, so if you input 0, then this NMOS is going to be off, as we see the analysis here. So it means this is an open circuit, and this one is just connected with the ground, so this is going to be just yeah, it's better to connect the PMOS on top always, because PMOS act weird if you connect with the ground, because if the input is 0, it's going to turn on. So you better connect the PMOS right here. Okay, so this is now P-type on top and N-type here. N-type. Now, okay, let's say input is 0. What's going to happen? P-type MOSFET is going to be turned on. So this is short circuit right now, which means whatever the voltage will pass through this, and the voltage we get the voltage output. So it's going to be turned on at this point. So we can say VO is equal to 1. But if the input is 0, so here we can say if in is equal to 0, V0 is 1. If the input is 1, what will happen? If it's 1, the PMOS is going to turn off. So this one makes it open circuit, and the NMOS connected to the ground, so nothing will happen. You get V output to be 0. Okay, so that's the CMOS behavior. Now let's see how we can build gates from this analysis. So for the to build the gates, what we do is there are especially the AND gate and OR gate, NAND gate, NOR gate. So NAND gate and NOR gates are kind of easy. Let's look at them first. So first, let's look at a NAND gate. For the NAND gate, what do they do is they connect this PMOS in in parallel like this. Let's look at the reason why. It doesn't have to be 2, it can be 3, 4 or anything. It behave like a NAND gate because let's see why it happens. Okay. And this is VDD and this is VDD, and they connect the NMOS in PMOS in parallel but NMOS in series. And both of them gonna have the input of A and B. You can either put A here, B here, A here, B here, or you can make a one wire for common for both of them and make this one an A. Okay, similarly connect a wire for both of them and make this one a B. Same thing, you can put it individually or you can put it together. So let's analyze the behavior. Okay, and also it's better to keep up with the order. Okay, so when I say keep up with the order, like from left to right and top to bottom. So here left to right, I name this as A, and the second one I name this as B. But I don't know if I can analyze if it connected in the other way, what will happen. We can analyze that as well, but usually this is better to put like this. And let's look at the logic gate. So A, B, we have 2 inputs. So the possible combinations are like, and you have to think the V output like this. Okay, and see what will be the output here. Okay, so let's say if it's two inputs, then there are like 4 possibilities. It can be either 0 0 0 1 or 1 0 or 1 1. These are the possibilities if you have 2 inputs. Now if it's 0 0, what's going to happen to the PMOS? You can see the top 2 are PMOS because the node attached at the end, and these 2 are NMOS. And if you put 0, both of them are going to be short circuit because it turns on when it's 0. So both of them are going to be short circuited, and this is going to be open circuited. So which means that bottom part is gone because these 2 are open circuit because NMOS is turned off when it's 0. So the bottom part is gone, but we have the VDD, and VDD and VO has a connection, which means the output is going to be 1. And A is 0, which means this one is turned on, and B is 1, which means this is turned off right here. So this is open circuited right now. And what about this one here? If we look at 0 1, 0 mean A is 0 mean this is open circuited for the NMOS, and this one is short circuited, but this one doesn't matter. The only thing that matters is, do we have a connection between VDD and V0? Yes, we have one connection. Like even though this B is open circuited due to this one, this A is a short circuit right here because of this 0. So which means this VDD and V0 has a connection, V output has a connection, which means there's going to be a 1 right here. And let's look at 1 0. So if A is 1, then this is right now open circuited, and if the B is 0, then this is short circuited. Now VDD and V0 has a connection. It doesn't matter what happens to the other things, you can just put 1 right here. And then 1 1 is the situation these two are going to be open circuited, which means there's no connection between VDD and V output. The only connection is these two NMOS are turned on, which means this is short circuit, but this is connected to the ground, which means whatever the V output here is going to be just 0. Okay, and if you look at this truth table, this is a NAND gate truth table, because if you don't know the NAND gate truth table, first you can think about AND gate. For the AND gate, if it's 0 0, it's going to be 0. If you see any 0 in the AND gate, it's going to turn all the things off. So if it's 0 0, it's 0. If it's 0 1 0, 1 0 0, only times the AND gate will be on is when both of them are 1. And NAND gate exactly the opposite. So here, whenever you have any 0, it's going to be 1. If you don't have any 0, that's the only situation is going to be 0. So this is a NAND gate right here. Okay, and from the NAND gate, we can design an AND gate as well. Okay, and the one we looked at on top, I don't know if you remember, I looked at one first, analyze one gate first. That is a NOT gate. So if you attach NAND gate plus a NOT gate, that's equivalent to AND gate. It is like, let's say you have a NAND gate like this. Okay, if you just put this AND gate, if you attach a NOT at the end, that's an AND gate. And if you put a NOT at the end, that's an AND gate. Okay, this is NAND plus NOT. So how does the diagram look like? We can see that here. So to design this one, what you have to do is just copy this diagram right here. Paste it here, and now we have a V output. What we do is we attach this V output for the input as the next one. Like if you look at my first design, we had a PMOS and NMOS alone. That is the NOT gate. Okay, if you have an input and that is attached with the PMOS on top and the NMOS on the bottom, that is a NOT gate. Okay, so now we have the new VO here, and this is the VDD, and whatever the output from here is going to be the input. And as we analyzed before, this is a NOT gate right here, and as we analyzed before, if we just consider this AB, we looked at the truth table, that is 1 1, no, like let's look at the possibilities first. 0 0 0 1, 1 0 and 1 1, and we know the output was at the time, like now we can say this one as C. That was similar to a NAND gate, so it means whenever there was zeros, like it's turned on, and it's only off when all of them are on. Okay, this is the truth table we got. Now let's see what happened in each situation right here. We already looked at before, but we can look at the truth table now. So if you put a 1 here, what will happen? This PMOS is gonna be open circuited, which means the V output is gonna be automatically 0, because whenever the PMOS is open circuited, that's it. There's no 1. It's just connected to the ground. So that's gonna be 0. We are just looking at the C, okay? We don't look at AB. AB just needed for this. We are just looking at C. If it's, we are looking at if it's 1 or 0. So if the input is 1, this is gonna be open circuited, and this is short circuited, which means this is 0. And again 1, 0, 0. And whenever, only when it's the only situation when the input is 0, that's the only situation the PMOS is going to be on, which means that's the only time the VDD is going to be connected to the V0. So that's the only situation it's going to be on. So you can see it is giving the AND gate truth table. So if you attach a NOT gate at the end of the AND gate, that will give you AND gate. So this is the AND gate right here. Okay. Similarly, you can build a OR gate with the truth table as well. I mean, you can build OR gates as well. Now let's see how to build OR gates. In order to build OR gates, you have to do the opposite of what we did here. Like for the AND gates, we attach the PMOS parallels. For the OR gates, you have to attach the PMOS in series and NMOS in parallels. Okay, you have to do the opposite. It doesn't matter 1, 2, or 3, whatever. If you wanna do the NOR gate behavior, you have to attach this PMOS in series and NMOS in parallels. Now let's look at an example. So let's say we have a PMOS, 2 PMOS in series. Okay, and then NMOS in parallels. So the NMOS input should be coming from, I mean VDD should be coming from this. Okay, so let's say this one is A, and you can either connect right to left or left to right. It doesn't matter. If you, when you consider the truth table, you will always get the NOR gate truth table. Okay, so let's go say this is B and this is VDD. Now let's look at the output, V output right here. Let's look at the truth table. So A, B, and then V output. Now if you have 2 inverters, there are 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So when it's both of them are 0, which means the PMOS is going to be on, and that's the situation. The VDD and on mean this is short circuited straight wire, so which means VDD and V0 has a connection, which means the output is going to be 1. And if one of them is open, like for example A is 0, A is short circuited, A has a wire, but B is 1, which means it's turned off because of the PMOS. If the input was 1 for the PMOS, it's going to be turned off, which means this is open, which means there's no connection between VDD and V0, because even though this is short circuited, this one is open, therefore nothing will pass here, which means this is 0. So if you see, as you can see, like since this is in series, if any one of them, like you can either put 3, 4, 5, If any one of them is open, that's it. There's no connection between VDD and V0. So this is going to be 0. So if one of them is input is 1, then you can automatically see that is 0. Okay. So this is like OR gate, NOR gate. In the OR gate, if you have 1 1, it's going to be turned on, like it's like addition. 0 plus 1 1, 1 plus 0 1, and only the 1 plus 1 also 1 as well. So not like really addition, but whenever you have a 1, the output is going to be 1. That's the OR gate behavior. But this is exactly the opposite of it. So you can see this is a NOR gate. And from the NOR gate also we can design OR gate. How we design is, this is the NOR gate right here, and if you attach NOT at the end, that's gonna give you OR gate. Okay, this is NOR plus NOT. And how do you attach NOT? Like this, you connect the wire here like this, and this is a NOT gate. You copy this, like I can literally do it right now. Copy this one, copy this one, and paste it over here and attach with this one, and now this is the OR gate. Okay, so that's all you have to do. Okay, so you have to put a NOT gate at the end of this, and that's gonna give you OR gate behavior. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.